Alright, so this demonstration is going to focus on a tool called Imanim, or perhaps if it's pronounced slightly differently in Hungarian, for those of you that do speak Hungarian. Not even sure if that actually is a translation directly to Hungarian. Nevertheless, this is a free tool that gives us the live three-dimensional presentation, interaction, rotation, and zoom in with the mouse, and also continuous animation of wave propagation, which really gives us the ability to manipulate two waves and optionally their superpositions. So we can actually look at the difference between, the differentiating signal strengths by modifying the amplitude, looking at the polarization, the wavelength, and even the phase difference. So feel free to download this tool. As you can see in front of you, it is from a website called enzim.hu, and if you of course go and Google that, you should be able to find that also pretty easily by just simply using Imanim. And I've already taken the liberty of downloading this tool, and we should be ready to rock and roll. So I say that, and we're almost there. So there we go. And as you can see from the diagram in front of you, the animation is actually showing us the wave 1. Now in each point, the electric field vector oscillates in a vertical direction. The wave propagates in the direction of the horizontal axis, and vary the wavelength and the amplitude of wave 1 to see how it actually affects the wave. So effectively what we could do at the amplitude setting is of course increase it. If those of you remember the good old days where you used to have these huge boom boxes in your motor vehicle, maybe some of you still do, your amplitude is literally adjusting your signal strength. So we can actually change it to a low amplitude or a high amplitude. Now just because you have the ability to create a lot more noise or to turn the sound up, that doesn't necessarily mean that has a crisper, clear signal. So you do need to understand within RF or radio frequency that it can cause distortion, just like if you actually put the music too loud. And naturally the wavelength is going to enable us to change the different frequencies. So that's the wave 1 as an example, showing you the vertical polarization. Wave 2, looking at the horizontal polarization. Once again, we can look at actually setting the amplitude something very similar, and we can look at the different phase. Now phase is basically when the signals are out of sync. If we have where we discuss 180 degrees out of sync or 180 degrees phase difference, effectively that could cause a lot of problems with actually cancelling out the signal. So this is just really a tool to be used for better understanding and learning RF, and at this level of this program we're going to keep a little bit to ourselves, because of course we do want you to sign up for either our mentored learning program or our over the internet live virtual training, where you actually have an instructor just like myself with video giving you all the instructions over a live video stream with a PowerPoint, the whole 9 yards.
So hopefully you all enjoyed watching that little demonstration. Remember, a lot of the software that I am demonstrating typically is free of charge, and I've given you all the different websites that you can go to download this. So we'll now start off with the access point. Now the access point in itself is obviously the main hub where all of your clients will connect to. And here's a point that people really don't always truly take note of, that radio frequency, and more specifically wireless networking, does not use a full duplex form of communication, meaning it doesn't send and receive simultaneously. Within wireless networking, it works very similar to a walkie-talkie. You can either talk, and then obviously the receiving party is going to be receiving that form of communication, or you could listen. So it is half duplex, which means that the whole structure of wireless networking has been modified from what we typically know from the good old Ethernet type cabling systems and networking. And that's predominantly because we don't actually truly see any of these packets flying across the air. So you have an array of clients that you're going to, of course, want to connect to those access points. And here's where really the tire hits the road. And the reason for that is there's a huge array of different types of implementation of standards. Well, when wireless started off, it started off as the 802.11 standard. And the 802.11 standard simply had specific features that would specify the speed, the types of techniques, the modulation techniques that were used to actually get that signal off of the actual system, off of the antenna and into the air. So one of the first things that we'll be talking about is the SSID, which is the service set ID, and that's something you really need to know when you want to connect to the different wireless networking. You're also going to see a few demonstrations as we go through this presentation whereby you can actually harden your security of your access point and thereby not broadcast the SSID. So the actual SSID really is a very important factor for people wanting to connect to the different access points. So another very important technology or component within wireless networking is your basic service set. And that's really one of your fundamental building blocks within your different wireless networks. So take this scenario in consideration. You may be working in a multi-story building complex, or you might be in a hotel that's got multiple floors. Typically speaking, most of the floors each have their own wireless access point. So we won't get into too much of the theory behind wireless networking. This, remember, the focus of this presentation is so that you can truly understand what are the pros and cons, and more specifically the security testing techniques we use and the security issues that you need to be aware of to make your wireless networking experience more secure. Now, we've been speaking about connecting to a central hub or a central access point, and that's where we really have a managed environment. But also you will now find with a lot of different types of personal digital assistants, cell phones, mobile phones, laptop computers, PSP portable game consoles, you name it, they all come with wireless built in. And the issue with those devices is that you don't always have to connect to a centralized access point. So with regards to the independent basic service set, that is used where you actually connect to other types of wireless devices in an ad hoc environment, meaning you don't actually have a central point that you actually connect to.